But yeah, so continuing on to time, what I really wanted to talk about is how we came up with time. Right now, I've actually done quite a lot of reading on time. And for some reason, I can't find an exact answer for why it is the way it is. Let me explain what it is first. So originally, before we have all these atomic clocks and, very precise measurements of time, what people used to do, and this is purely off the internet, so I can't really go deep into it, it's basically they used to have this thing called the ephemeris, which listed all the orbital positions of different planets in the sky. And when they compared the current position and how these objects in the sky were moving relative to each other, and when they compared that to this thing called the ephemeris, they literally came up. This is the part I couldn't find. I really couldn't find where they came up with this number. I swear, I tried. I really couldn't. But so this number, they got to this pretty preposterous number. I don't even know how. And it's 31,556,925.974 of these time intervals that they made up makes up 1 year. And that's basically how it was defined. And again, I tried looking, man, guys. I tried looking for why it was defined like this, because I want to know. To be honest, I really do. And we can have a quick discussion on why we think it was like this. But basically, the way they defined it, this was the length of the year 1900, only that year. Why? Because technically, exactly every year, the length changes just about a bit. So obviously, with technology advancements and stuff like that, they couldn't keep doing this because every single year, the positions of the planets change. It's not absolute. So this ephemeris that they had, this list of orbital positions, didn't really work because every year it would change a little bit, here and there because of precession. So with increase in technology, they found a perfect atom to do their job for them. They found cesium-133. And the reason they found this atom is because once this atom is hit by laser, right, the outermost layer of the atom, it transitions between these two levels. It oscillates back and forth between these two levels. And that's what we call a hyperfine transition, right? And when researchers calculated how many of these oscillations are required to represent one ephemeris time interval, right? Like one ephemeris time interval, they found this number, right? I'm just going to repeat this number. Probably won't mean much, but 9,192,631,770 oscillations of the hyperfine transition. That makes up 1 second. And because that obviously doesn't change, right? Because the outermost layers of the same isotope will obviously not change in their oscillation period. So when it's hit obviously with a certain laser, it oscillates at this. And these number of oscillations make up what we call today as 1 second.
Okay, but at the end of the day, even though we have this atomic clock,
yes,
that defines 1 second. One second doesn't mean anything.
At the end of the day, it's what we defined. It's all based around, I think the entire idea is based around the Earth, around the sun. Because the second is kind of, if you think about it, dependent on the year, right? Like the second, like the way we defined it, is perfectly dependent on how long 1 year is. And then when we take that knowledge, we can think about, it kind of makes sense because 1 year, should have the exact same amount of time intervals every year. Like that shouldn't change. Mm-hmm. Even though the planets and everything is changing, like orbital positions, even though all of that is changing, the definition of a second shouldn't change. So that's when they changed it to the cesium idea with this atomic clock. And they made it a lot more precise such that obviously it never changes. But as you very well said, it's not really it's not a universal constant. The second, it's not a universal constant. It's simply how we have defined this time interval. Like another alien civilization, if they're measuring, I don't know, one second instead of second. I don't know. Maybe it's in their language. 1 second, right? So the second might not be the same number of oscillations. Maybe instead of 9.1 billion, it's, I don't know, 8 billion. I don't know, because their planet what am I trying to say? Because their planet revolves at a certain different distance than Earth. So it all depends on how we define it. And I think especially with, time, it's all that we've defined time. It's not that it's really a thing. We've defined the interval of time. So it's not a universal constant. And I think that's a pretty important, idea.